Hi everyone, I'm Jim Bagladia. Good evening, thanks for coming. Just want to say a few quick words to get us started. Wanted to do a couple of announcements and then we'll turn things over to our speakers. So first off, tonight we have a great session and a great set of speakers lined up. But we're also looking for any ideas or topics that you might have for the next few events that we're planning. We do have a session planned out for September 17th. And that session we're going to do as a joint session with the Silicon Valley Forum. So I want to ask Dave Nielsen, who's chair of the Cloud and Virtualization SIG, to quickly tell us about the September session. Dave?
Thanks, Jim. I'll make this really quick. So, have any of you have heard of Chris Richardson? Really? No hands? Nobody knows him? Okay, of course, yeah. So, he's the originator of the Cloud Foundry idea way before it is what it is today. But he's going to be giving a talk on how to build applications for microservices. So it should be a good talk, and we hope you will join. And there's a company named Appcedo who has decided to sponsor the event so that we can make it open to everyone. So we hope we will see you there, and that is September 17th. In Mountain. Thank you.
Yeah, so we'll get that posted in a couple of days on the meetup site, so look for that and hope to see you all over there. Chris, by the way, if you have seen any of his presentations on Java or RX Java, I mean, he's excellent in taking a very complex topic and breaking it down into simple terms and presenting that. So next, wanted to just quickly thank Cisco for hosting the event and their sponsorship. There were a lot of, thank you. So Leif Martins and the whole event team, as well as Vivian Shen from Cisco Corporate, have done a great job pulling this together. And I want to invite Jeff Arnold from the Cisco Cloud Services team. He is OpenStack architect there, and he's going to say a few words and help us introduce the speakers. Jeff?
So thanks for coming. At this point, I am standing in for Ken Owens, who is the CTO of Cloud Services at Cisco, and he is the Cisco sponsor of this event. Unfortunately, he can't be here. He's somewhere in the Midwest, but probably watching on WebEx. We have 4 speakers, actually 5, because we have one tag team this evening. I'm going to list them in reverse order, ending up with the guy saying to my left, who needs a little introduction, but I'll try and embarrass him as well. The final speaker will be Damien from a wonderful and interesting startup in the Docker space. This is, I mean, we're talking about microservices and containers for microservices. This is absolutely where the cutting edge of this stuff is. Before that, we got, I'm sorry, blank on Sudhir Nitesh from Netflix, and where over the last few years, people have been demonstrating exactly how to transform the entire business into nothing but microservices running in the cloud. The poster-child application, poster-child environment for the cloud services and microservices. Before that, I'm going to be saying a few words about some work which I did at Amazon and Yahoo on microservices before we called them microservices. Hands up people who were working on cloud before we called it cloud. Quite a few of us here. And then to start all of this off, we have Adrian Cockroft, who is probably more comfortable in sitting at the behind the wheel of a McLaren or a Boxer going down Laguna. But he is, I don't know how I don't know if we ever intended this to happen, but he's in everything to Mr. Cloud in the entire industry. And this is yeah, it doesn't make sense. It's not. But none of these things. That's right. And he and I have worked together off and on for many years. When he was doing performance engineering at Sun, and the Sun connection through all of this is actually very strong. So, without more ado, Adrian Cockroft.
So is this on? Okay. Actually, just to say a few things about Jeff. I've known Jeff a long time, and I get all these people saying, "Will you help me with cloud architecture stuff?" And often there's two kinds of cloud architecture. There's building clouds, and that's what Jeff does, and then there's using clouds, and that's kind of what I do. And that's kind of how I think about the two different flavors of cloud architecture. How to use a cloud to run applications is what I have concerned myself with, and Jeff is a really deep expert in how to build clouds so that you can use them, right? So we kind of meet in the middle of the API or something. Okay, well, thanks very much for inviting me to be opening speaker for this meetup, and it's great to see everybody, a lot of familiar faces here. I'm going to run through some slides which are variants of things that I've been giving. I've given this talk quite a few times recently, or various versions of it, and it sort of got tuned to the things that people seem to care about, and it really talks about why people are starting to worry about speed of development and how microservices is part of the answer to getting development speed up. And that's kind of starting off with the sort of business view of why you need that. But first of all, I'll explain where I've come from. There we are. So this is a summary. This is my resume, basically. I've spent the last few years out there tweeting and baffling late adopters as a service, as sort of a summary of what it's like for me to be out there giving talks. So you probably aren't so much the late adopters, but that's kind of what it feels like when I go to big old companies and they're sort of staring at my slides going, this is horrific. Who would ever want to do that kind of thing? And so we have all these different reactions to the talks that I've been giving over the years. In 2009, Netflix, there was actually an article in the New York Times saying, hey, Netflix is going to do cloud on Amazon. People just flat out didn't even believe it. They didn't pay any attention at all. In 2010, the consensus moved on to that we were trying to do something and it wasn't going to work. And at the beginning of 2010, basically nothing customer-facing was running in the cloud. By the end of the year, most of the customer-facing parts of Netflix were running in the cloud. So then, in 2011, they said, well, okay, it seems to work for Netflix, but Netflix is a weird unicorn, and nobody. That's when I adopted the cloud icon as my icon, basically, for Twitter. That no one else will ever want to do cloud like that. You're very, very special, right? And then there were a few big outages where Netflix didn't go down and everyone else went down, and then people seemed to notice we were developing code really quickly and products really quickly. And then it seemed to scale, and it had all these nice properties, and I kept on doing the talks, and more people from Netflix started doing talks. And so it moved on to the next thing in 2012, was where we really like to do that, but we can't because we can't figure out how to get there from where we are. The gap is too big, although this looks like a nice place to go. And then in 2012, 2013, over 40 Netflix projects were open sourced by some of the people in this room. And last year I was going out doing talks and running into more and more people saying, yeah, we want you to come and talk to us because we're already trying to use the Netflix code. We want to learn more about it and how that works and all those kinds of things. So this is kind of the progression over 4 or 5 years of me going out doing really roughly the same general idea of trying to explain what the hell we were doing at Netflix at the time. So by the end of last year I left Netflix. I'm going to explain sort of what was going on there in a minute, but what did I learn from the time at Netflix? And what it really comes down to is speed wins. No one ever went to you and said, please slow down the pace of product development, you're going too quickly, I want you to take longer to develop this software, right? And the other thing that's happened is everything is software now. Basically the software is the long pole in almost every product development. Things that didn't used to have software in now are largely software. Cars are software. Things are software, or the Internet of Things. Everything, companies that never used to have to deal with software are now finding their livelihood depends upon them being good at doing software. So, given that you've got that, you then want to get product development to go faster, take friction out of it, so you use a high trust, low process environment, you take the handoffs away from between teams so that you just do things directly. So that comes down to Netflix, to a freedom and responsibility culture, where you don't do your own heavy lifting, you contract out as much stuff as you can to SaaS applications and things like that, and cloud infrastructure. And then my role as architect was not to control the architecture, it was to discover the architecture that the engineers were producing, kept saying, well, that looks neat, and then talk about it to some other people and say, oh, that sounds extra neat. Let's figure out how to generalize that, rewrite it a bit, tidy it up, document it. Oh, and by the way, that's the right time to open source it, stick it on GitHub, and then you find that more people internally will use it, partly because it's nicely documented and separable, and it's modularized, and it's on GitHub. So there were two things. One is that internal code use gets better if you open source the code. which sounds like it shouldn't be needed to do that, but it happens. The other thing is if you want your developers to document and clean up their code, open sourcing it, they'll work nights and weekends. Because their name is on GitHub next to it, and they don't want crappy code on GitHub with their name on it. And it is the best way I've ever found for cleaning code up. Was that, would you like to open source that? I think I need to rewrite it from scratch. Give me a week, right? And it is incredibly strong. It was an unexpected benefit. It wasn't why Netflix started doing open source. It was probably the biggest short-term payback for doing open source, so really encourage that. The other thing is, if you take what you did in the data center and just do that in cloud, you get speed up and you get more agility and you can make things automatable. But there's a whole set of things that you would never have attempted to do in your data center that you can do in cloud. So that's the interesting thing. Things that used to be impossible become instant. There was a project at Netflix where we thought, well, what happens if we have some machines in Brazil? Can we speed things up? Now, if anyone ever tried to send hardware to Brazil, they know it's sort of 6 months. You probably have to give the right people exactly the right amount of money, sometimes under the table perhaps. It's a very complicated process to get hardware to Brazil. But Amazon already has some there, so you can fire up a machine for a few days or a few machines for a few days, try something out, shut it down again, you're done. Something that we would be laughed out of the office of your CIO for even suggesting, right? Other times, creating a large-scale global cluster to run a Cassandra database. 200 terabytes of SSD was created from scratch off a hallway conversation. About 20 minutes later, it was running. There was no approvals process. It was in 6 different data centers on both sides of the country. And then, over the next few days, we ran some benchmarks and proved that something worked. So we could go to the rest of engineering saying, this pattern works and has these characteristics. And they went, and when you go to an argument with data or working code, you tend to win. So there was going to be a big argument about how globally distributed data was going to work. And we said, well, have benchmarks, this works, this is how it behaves. So you end up being able to try things out and have real demos of infrastructure, which you cannot do at a data center. There's just no way that you could say, I need machines in 6 data centers for 3 days. You can't do that. Right? So that's some of the things that I really, the light bulb going on over the time I spent at Netflix. So, actually the video thing's covering up some of this. This is at enterpriseadoption.com. Enterprise IT adoption? Yeah. So what happens is, enterprise IT tend to ignore things like iPhones or cloud or whatever for as long as possible. But Netflix got out ahead of the market. In 2009, I was out there playing around with this stuff. My animations aren't working because of the way we uploaded this stuff. The rest of the world goes through something, and then enterprise IT finally at the end of things basically says, okay, I guess we have to do it because everyone else has already done it. And there's this I put the Battery Ventures logo there. So I'm playing around in this intersection now where basically enterprise IT is colliding with cloud head-on right now. The way it feels to me is that a bunch of enterprise IT people went to Las Vegas last November for the Amazon reInvent show and said, everyone else is here. And they all seem to be doing it. Are we doing it? Yeah, we're doing it. Yeah, we're thinking about it? Yeah, maybe. Okay, let's put this on our 2014 plan, right? And then it came to January, and all of a sudden, doing cloud properly on AWS became 2014 plan for every enterprise worth talking about. And they all suddenly started doing it. And there was almost like a light switch going on in the first quarter of this year, where a lot of people that were kicking the tires suddenly started piling into it. Now, they aren't there yet, but they are. The projects have launched and they're dialing in, so that we've actually hit this point where they're just trying to digest it. So I'm out there, and the opportunity for me is to go and talk to these big enterprises, find the gaps, find the software companies that need investment that can fill those gaps and help take them to cloud, and generally mess around in this space. So that's my new job. So basically, this is they've been poking at it with a long stick for several years, and finally they went, okay, yes, we'll do this. Not everyone, but the great majority of people. It's that crossing the chasm moment, and I think the timing has really happened. So this is the problem when they do that, is that enterprise AT knows how to do all kinds of things, but these things aren't true anymore. For example, they know that if you file a ticket, and you wait a couple of months, a VM will appear, and then you can install code on it, and you can jealously guard that VM, and you kind of curate it, maybe use Chef or Puppet to put different things on it. They don't really understand that you can create 500 machines automatically in 3 minutes just by clicking a button or making an API call. So you have your mindset is built around things being expensive, like getting machines, as opposed to things being effectively free, like deploying autoscalers. So let's look at those assumptions. And what you basically have is the difference between incumbents and disruptors are the assumptions they make. And then you optimize your business model around the assumptions you made. Certain things are expensive, certain things are cheap. You can make big money out of solving problems with things that are expensive. But then over time, these things suddenly become cheap or gradually become cheap. But your business model still assumes they're expensive. So somebody will come in and disrupt you with a new way of doing things that makes machines ephemeral. The whole sort of microservices architecture and cloud native models assume that you can create and destroy machines at willy-nilly, automatically. You don't have to file a ticket to get a machine, right? That's the past. So let's just look at one of those assumptions, and this is kind of the fundamental one that leads me to why microservices are interesting. And this is that if anything goes wrong, you just add a process step and a handoff, and it will never go wrong again. And you keep doing that until nothing ever goes wrong, right? So what's the problem here? You have a new problem that it takes too long to get anything done, because your company processes start to look like scar tissue from everything that ever went wrong. If you ever look at a company's HR manual, you'll find that's full of scar tissue from every time an employee did something bad, right? And there are laws in government, there are laws that are based off of things that companies did wrong once, Sarbanes-Oxley or whatever, right? And there are companies that caused that, they will forever have that scar tissue in their HR manuals and things. So we're suffering from this all the time, and the trick is to basically blow through that. Get rid of that scar tissue and get things done. So let's look at product development. If you're doing non-cloud product development, you have infrastructure cloud. This thing is not animating properly, so anyway, it shouldn't have that IS nothing. You basically ignore the little X. You have a business need, you spend weeks documenting it, you spend weeks arguing with management, weeks arguing with hardware vendors and provisioning people and where to put your stuff in your data center, and eventually, about a year later, you get your product out and customers say it sucks, and then you go back to the product manager who's left and the developers that wrote it that aren't working on that project anymore, and there's nobody cares. So you have to start a completely new project to fix this thing that sucks, right? And then you do that about every year or two, maybe it gets slightly better. So that's a problem. So if you get rid of the bit in the middle, you can speed things up. And you can build something that's a little bit more like a typical agile process that maybe takes a month or so to get through. So product manager works with a development team, hands off to QA, and then operations deploy it, and then BI analytics feedback into it. So that's a reasonable kind of loop, and there's quite a lot of people building SaaS applications, in particular, running on a loop like that, using infrastructure as a service. So you're using, private or public cloud from a number of different vendors to do this, but you can actually take the box there for the right was the deployment box. So what we can do is replace that with platform as a service to try and speed things up a bit more, because this is still taking weeks to months to do. When you do that, you basically have a product manager working on one feature which a developer will deploy independently as a update using the platform. So they're not having to go through operations. They have tooling that delivers everything to production, and the developers run it themselves. But this is just for an individual feature. So instead of gathering all these features together, we're doing it one feature at a time. And you can get around this loop in maybe a week or a few days, depending on how big the feature is. So you end up with this thing where you've got a PaaS-based product, and the bit in the middle that you're actually working on building things, you could actually replace that with SaaS if you wanted. But PaaS-based products, Heroku, Cloud Foundry, Google App Engine, the Netflix OSS suite of open source projects basically form a PaaS that you can sort of put together piece by piece Apsera is a spin-off from Cloud Foundry. Docker fits in this as a container that's basically turning into its own set of platforms. And Continuity is a PaaS for doing business analytics kind of development. So, yeah, and you can speed this up. If everyone's building the same apps over and over again to do the same HR things or whatever, you just use SaaS. So there's Salesforce and ADT for doing payroll and all those kinds of things. So that's where you basically get rid of the bit in the middle. So what happened each time here is the cost and size and risk of change reduced and the rate of change increased. So you're speeding things up, but you're doing less risky things as you're going faster. And this is the OODA loop that you go around. You start off by observing something, you measure customers, you find a land grab opportunity, something, Netflix is doing land grabs in content and countries, basically. They're grabbing, new TV series and they're launching them in Germany or whatever they're doing this fall. You see a competitor make a move, you want to respond to that as quickly as possible. Or you find a bunch of customers with a pain point. Maybe there's calls into CS that something's broken, or you notice that on your customer acquisition funnel you're losing too many customers at a certain step, right? So you do some analysis, you pull that data in. That's where the big data piece kicks in. You model hypotheses about what to do about it. You're typically looking at unstructured data because you're trying to answer a question that no one has ever asked before, and the data to answer that question isn't in your BI system. It's not something that MicroStrategy is going to answer for you out of your Teradata or whatever. It's something that you're going to have to rummage around in logs to get. So then it's then up to culture to go fast. You've had a plan a response, just do it and share the plans. If you have to go and get permission to fix that customer problem, and escalate all the way up to VP or whatever to get permission to roll something out, then you're going too slow. So this is one feature at a time, one fix at a time. People are empowered to make the fixes. There's no handoffs in the system. You're going and just doing it. And then use cloud to deliver. So there's incremental features, automatic deployment. You launch an A/B test to protect. If it's a new feature, you put it behind an A/B test so that the code doesn't break anyone else's system. And new customers don't see it unless they're in that test, so you figure things out using hypothesis testing. And then you get around, you measure the customers, and you do it again. So you go around this loop. And if you're going kind of current state of the art, I'd say, is to get around this sort of about once a week or every 2 weeks, but every team can do this independently. And that's kind of the microservices piece, is to do this with every team independently rather than everybody in lockstep in the whole company trying to do this in one go. So if you do it in lockstep with a monolithic application, there's a release plan which all the PMs get together, product managers get together and agree a release plan for what's going to be in version N of your product. They farm out the work to the developers, and when all the developers are finished, QA gets to integrate all this together, and then they throw it over the wall to ops, who then replace the old release with the new release. This is the monolithic way of doing updates. And the problem here is that the old code is no longer running at that point. There's a bit of a handover where you phase things in, but basically once you're on the new release, the old code isn't there, and you've replaced everything in this monolith. So the way it looks with a microservices architecture is there are lots of individual release plans with individual product managers working with individual teams of developers at whatever pace they want, at whatever cycle of updates they want. And they deploy features to production independently, and it does not replace the original code. So you can leave the old release running because you're deploying new instances of running the new code, and you're leaving the old instance running the old code. So now the experience the customer gets depends on the route they take through your services. If you route customers to the old code, they get exactly the experience they used to have. If you route them to the new code, then they get the new experience. And you can control that, but you have to build some tooling to help solve that problem. So this is a couple of patterns here. We can call this non-destructive production updates. And this is a very key concept because this lets you run incredibly fast and be incredibly safe, because you don't break things when you don't remove things from production. Existing services are unchanged, old code's still running. You deploy new code as a new service group, and there's no impact to production until you change the traffic routing. And then if it's broken, you flip the traffic routing back, and they see the old code again. So if you break something, you can fix it very quickly. So you're using A/B tests, feature flags, and version routing to control traffic, and that sounds complicated, but it's a tooling piece. It's a piece of tooling and infrastructure that your platform should handle. And once you've got that in place, you'll never want to live without it again, because it's a very powerful way of controlling things and managing what you've got. The way you think about this, if you're rolling out a new feature, is the first user of that feature, the first person in the test cell is you, the developer, and no one else gets to see it until you're happy that it looks kind of like it's working. You could deploy totally broken services out there. If you're the only one that knows it's broken, it doesn't matter, right? This isn't deploying broken code to production, doesn't matter, right? That's something, that freaks some people out when they first hear it, but if you think about what's going on here, it works. And then eventually you add the QA engineers, and then once they're happy that it works, you put the product manager on it. When they're happy, then you turn it on for a cohort of A/B test customers, typically new customers, because they have never seen the old system, right? So they come in and they figure it out, and then if it works better than the old code, then you turn it on for everybody. So that's kind of the flow of ideas getting out.
Time for a quick question.
Sure.
So OSGI, actually that immutable code really speaks to me quite a bit. It's a process, and the A/B test is critical. But OSGI as a strategy, what's your thoughts on that? To me, that's like changed a lot of stuff.
I don't really have an opinion on OSGI. I haven't looked at it in enough detail.
Cool.
This is a strategy which works if you assume that machines are cheap and fungible and ephemeral, and you can create as many as you want, and you can destroy them. If you're stuck in the world of running in data centers where you file a ticket to get a VM and you have to update what is on that VM because you spent months getting it, right? It's a very, very different mindset. So this is making the assumption that getting machines is an easy and cheap thing to do, and turning them off again means you stop paying for them. And a lot of the cost optimization of cloud is around turning stuff off when you stop using it. And assuming it gets radically, incredibly cheap if you don't have to pay for it when you're not using it. How many QA engineers really are you working in that QA environment at midnight on a Sunday? It's not, hopefully not too many. Okay, so this is a disruptor. This is the continuous delivery model, and the microservices model is disrupting companies, because companies that have adopted this are finding that they're able to reliably roll out new features incredibly quickly, and people that don't are getting stuck behind. They're going around that loop. If it takes you 6 months or a year to go around that OODA loop, and your competitors going around it in weeks to months, you rapidly fall behind. You're not learning as a company. You're not able to test your hypotheses, and you'll rapidly fall behind, and eventually go out of business, or at least have reduced sales and being disrupted by them. So this is the problem. If you're being disrupted, you're like Wile E. Coyote. You ran off a cliff and you haven't fallen down yet because you haven't looked down, so you haven't noticed that your assumptions have changed. So make the assumptions explicit. What assumptions are you really making in your business? And what trends are happening? Things like solid-state disks are getting cheaper. Well, they still cost more than regular disks, but it's getting to the point now where nobody cares, and you just use SSDs for everything, pretty much. And eventually they will probably be cheaper than regular disks for everything. Listen to people who aren't your customers. This is something that's very important for the big incumbents. People in the storage business they're building all these hyper-converged infrastructure with all these disks and stuff, and all of these tooling and stuff like that. Meanwhile, Netflix has a bunch of Cassandra instances that they got from Amazon with solid-state disks on them, and a Java distributed systems developer managing it. No storage engineers, no SAN engineers, no backup engineers, no tooling from the storage industry at all, right? This is open source Java code, and a Java distributed systems developer replacing an entire industry, a huge industry of storage just disappeared, right? The storage industry never hears about this because there's no one talking to them, because they didn't buy anything from it, right? So that is an industry that's being disrupted because they are not hearing from the customers that are disappearing, and that revenue is just going to disappear eventually. So what you have to do is follow developer adoption, not IT spend, right? You can be, let's say you've got a product, let's say you're a big virtualization vendor, and you have billions of dollars of revenue from your product, and you're being replaced by something that's an open source tool that maybe has 1% revenue for a bit of service support kind of stuff. So if you're being replaced, let's say your product, whatever you're doing is being replaced by a thing that is 1% of the cost of the thing you currently have, right? At the point where you have 90% of your revenue left, you only have 10% of the market left. Think about that, right? So 90% of the market goes away, and in terms of actual adoption, and that accounts for 10% of your revenue. And you still feel good because you still have 90% of your revenue, but you've lost almost all of your market. And that last 10% of the market collapses really quickly. And all of a sudden you go, hey, what happened to my market? Right? It suddenly disappears from you. But if you watch developer adoption, you can see something happen. So you see things like Docker in particular, which has now got fantastic developer adoption. It's just become the default way everybody does containers in a very short period of time. How many dollars are there in Docker? It's near zero. It's near enough zeros to not matter. How many dollars are in VMware? Billions, large numbers, right? So where is the future, right? VMware is trying to figure out how to deal with Docker. That's what if they're paying attention, I know they are. They're trying to work out what is their Docker strategy, right? Because everyone has to have one. And then you get this evolution where things that used to be interesting products become services, which are still interesting, and then they become utilities, and it doesn't matter anymore. So you need to move those things out. They become undifferentiated heavy lifting. You just push them out to be something you buy from somebody else. It doesn't give you any differentiation if everyone can buy it as a utility. And then the sort of DevOps reorg that you need to do to reorganize your teams for speed of execution, you have to basically, instead of having vertical silos with handoffs between them, you do cross-cutting teams that own everything they need to deliver a product with APIs to make it happen. So that's kind of the business case for doing this, and I've done this talk sometimes sort of very, CIO level management. I kind of stop there. But for a more developer audience, I'm going to talk a bit more about microservices and how that addresses this. So this is my definition for microservices. A loosely coupled service-oriented architecture with bounded context. Bounded context comes from a book called Domain-Driven Design, or the Domain-Driven Design idea by Eric Evans. It's worth reading if you haven't seen it. The idea of a bounded context is how much do you need to know to be productive about something? And if it's got a bounded context, then I don't need to know anything beyond the bounds. So you get people that can adopt, let's say I have a microservice and it's fairly small and simple, and it's got very well-defined interfaces, and it can be operated independently of everything else. I can put somebody on that microservice, they can be productive very quickly, they're less likely to create bugs, the thing is just going to be much more rapid development. If you've got a very unbounded context and everything is tangled together, then it's tightly coupled. I mean, and you can tell this, we have microservices, okay, but what does a release look like? Oh, we update all of them at the same time. We take a day and we take a Saturday night and we shut everything down and we upgrade all our microservices at once. And that is not microservices. Well, they are services, but that's more like the original sort of SOA type of death by SOA thing, where everything was so tightly coupled that you couldn't change anything independently. So think about microservices as being, the key thing here is that you've got to be able to update them independently, and that independence is part of being a bounded context, right? And think of also, let's say you're doing mobile application development and you're putting something on an iPhone, and most mobile apps nowadays talk to maybe 10 different back-end services. You've got a bit of Facebook login and some Google Maps and some Foursquare check-ins and some whatever, Twitter, and then you've got all of the things like Catchpoint and whatever for monitoring it. And by the time you've connected to all these services and then you roll out your app, if you were tightly coupled to those apps and you had to go around and talk to all of those vendors before you could push your code, that's tightly coupled, right? So think of all of the other teams that you work with as being like other things on the internet that have an API. And there is an assumption that those APIs are reasonably stable and they're forward compatible, and that's the typical kind of contract. And the Google Maps API should not break every Google Maps application without warning, right? It has to stay compatible. It can evolve forward, but there's some elements of compatibility there. So think of it that you're building, it's like developing on the internet. So there isn't really anything new in developing in a microservices world. It's much more like developing on the internet, using internet APIs in a small company surrounded by lots of other services that you can use. So treat the other groups in your company, if you're doing a large scale one of these, as if they were those other companies. So what we're trying to do here is separate concerns, really. And one of the things that happens is Conways Law basically says that the code that is written by an organization will eventually resemble the communication structure of that organization, right? So what you do is you figure out what structure you want your code to have, and then do a reorg to make your organization look like that, right? If you want to have, a group of microservices do something, form a group that would own them, and probably you'd have one engineer per service to go build them. And then you can look at your architecture and almost see the names of the people that wrote it and the manager of the team that built this group of machines. And that's kind of the way the Netflix architecture works, or it worked before it got too complicated. But as it grew out, that's what it looked like. The other thing is that the back-end stores for these are per service and per group. So you don't have one common back-end, because now you've taken all your microservices and you've locked yourself in. If you have to do alter table on your MySQL schema and take everything down and lock everything and move it forward as a chunk, you haven't loosely coupled it. So you have to deal with the fact that there are lots and lots of independent data stores, and they are loosely coupled, and they aren't in sync, and they aren't consistent, and there's foreign keys that get wrong, and you have to have a sort of something that looks like an MDM, a metadata management thing, which goes around cleaning them up. Right? You can buy MDM products, but you can also just build something that goes and says, everything that has a subscriber somewhere, subscriber ID in it, every independent database that has a subscriber ID in it, you write a checker that goes and makes sure the subscriber IDs are the same, all exist in all of them, and none of them have it missing, and none have any extra ones, right? You just do that consistency check. And yeah, I know those big, nice relational databases did that for you, but they're coupling you together too much, and they don't scale, and you have to kind of find a way to break everything up and deal with it. You really want microservices to be single function, I think, in kind of a single verb or a single well-defined thing. You also want them to be at a similar point in their evolution. So if you've got a microservice that contains a whole bunch of functionality that's very stable and is somewhat critical to running your service, and you're trying to add a bunch of really, really new code that you're needing to iterate really quickly on, it's probably best to separate those two services. Initially may have two microservices, have one that's got the old code which you leave alone and it's just running and you don't touch it, and then the other one that you're changing very, very rapidly. And you only call this other one when you need this new functionality. And once it all settles down, maybe you think, these things really belong together and there's some efficiencies so you can actually join them back together. But what typically happens, I've seen many more cases where services end up getting so big that they need to be split apart. And quite often that's the outcome. So there's relatively few cases where I've seen services being joined together. It's mostly in the opposite direction. You have builds for each microservice. So you go to your repository and you pull in all the different components that you want to build it from. And it's now got its own sort of inventory of things, its own manifest. So these are the versions of the jar files I built with, or whatever language you're using. And this other one here is built with a totally different set of jar files. And everything's still fine, they still work, right? And at some point you want to retire old versions of jar files and you go around cleaning things up. But you can introduce new versions of things really easily, but it becomes a little bit harder to take away the old versions, right? So that asymmetry is very useful, right? You don't want to have to replace it, make it dangerous to introduce a new thing. You want to make it easy to introduce a new thing. Okay.
To keep things loosely coupled and allow for a lot of rapid change, you need a lot of versions of these services running at the same time. So there's some version management, and you hit on version routing before.
Yeah.
Can you talk about some tools that you might know that can help in managing all this?
So version management and routing is an issue. I talk a bit more about that later. This is an area where the tooling needs to be developed. So thinking about microservices as a kind of somewhat new concept, I'll talk a bit later on about some of the challenges with microservices. And I should probably just dash to the end of this and take questions at the end, actually. Otherwise, I won't get to the end. Okay, so You want to deploy in a container. It doesn't really matter what the container is. It's just that you should have a container because your tooling knows how to deploy containers. And you just put whatever code is in the container is what gets deployed. And then the other thing is to make sure your business logic is stateless. And hopefully most of you have heard of the cattle versus pets analogy, but I'll just run it by you anyway. If you have a machine in production and you care about it and you know it by name, and if it goes down everyone gets sad, that's a pet, right? If you have a herd of cattle, a pile of machines, and think of a herd of cattle that is like a dairy herd, because it's a nicer analogy. How many gallons of milk did I get today? Oh, I got a little bit less than yesterday. Oh, 2 of them died last night. Oh, okay. Well, let's just get some more. Right? Well, which ones were they? Oh, number 473 and number 926. I don't really have names for them, right? I just know that there's a herd, right? And as long as the herd has enough things in it to support whatever I currently need from that herd, I'm fine. And it could be beef or milk, it doesn't really matter. But conceptually, what we want to do is have herds of machines in production. The sort of customer-facing, highly available services should all be herds. And you should be able to shoot any machine and have it automatically be replaced by another member of the herd at any time. And that's the kind of the model that the Netflix environment's built on, and that most of these microservice environments are built on. So you want to avoid building these snowflake systems and having unique machines that could take you down if anything goes wrong.
Question. So in environments where you have stateful applications like on-premise, and then if you're looking to migrate them over to the cloud, there is obviously a challenge where the application is stateful, and you migrate it to the cloud, and it's not going to be able to easily federate around that.
Sure.
So how does the microservice kind of come to, or does it come to add value?
Okay, so the question is about stateful services. So put the state in a state tier, right? Put it in a Cassandra or MySQL or whatever. Don't build stateful services. So re-architect to do that. So it's very hard to take a data center oriented application that assumes that it's in a data center and isn't ephemeral. And you've got pets, right? Yes, pets get unhappy if you put them in the cloud and you kill them, right? I mean, I'm sorry. You need to re-architect your application really, and that's part of the transition here. But I need to get on with this. So if you have a stateful layer that's built on ephemeral instances, and Cassandra is a good example of this, or not the only one. The individual Cassandra nodes are all triple replicated. All data is triple replicated. You can kill any one Cassandra node. You still have 2 copies of the data. Everything keeps running normally. And then as the system will automatically replace that member of the herd. And it's a bit more specialized than just a completely stateless system. But when it gets replaced, it sucks the data in, brings itself back up, and sort of resolves itself, if you're familiar with sort of disk mirroring. Sort of it kind of like disk remirrors itself to have all the data on it. So this happens automatically. You can use chaos monkeys to shoot the Cassandra nodes the same way as you can shoot the stateful nodes. But you've got to have a service which has got replication built into it to do that in the stateful layer. So Netflix OSS, we've got to talk a bit later from Netflix, but this is an example of a stateless microservice-based business logic, immutable code, you get instant rollback, auto-scale capacity, automatic deployment updates, and then it's also distributed across zones and regions very broadly. And then the data stores are primarily denormalized single function, NoSQL data stores. There's lots and lots of different Cassandra clusters, each holding a single table that is owned by one team that has just got their data in it. So sort of the social team that's doing Facebook integration has its own Cassandra cluster with its stuff in it, and it just has their things. And if it goes down, it takes out the social service. It doesn't take out anything else. Everyone else will talk to the social service to get at that data, something like that. So there's lots of projects. The main problem that people have had with Netflix is this technical indigestion problem. There's just too much information, and it takes too long to figure out how to use it. Jonathan in the back is one of the guys from the IBM team that's probably spent the most time trying to figure out how to use the Netflix OSS stuff, and they've had some good luck with it. There are a few other companies that have used bits and pieces of Netflix, but as a platform to adopt, it's incredibly rich, very scalable, and there's a lot of adoption time to really get it going. There are other platforms which are much easier to adopt, but when you finally get to it, they don't scale as well, or they don't have the distribution models and things like that. So it's kind of you get what you pay for really in terms of the investment you put in it. The latest new thing is the security monkey. That's the bottom icon below the chaos monkey, which monitors your AWS security groups and S3 bucket permissions and complains if you've done anything stupid there. We'll talk a bit about open source ecosystems. This is something that's really happened in the last few years. The best code you can get is open source. You don't go to the big software vendors to get products now if you're trying to build large-scale, web-scale microservice systems. Because the code that implements this was written at Twitter and Yahoo and Google and Facebook and Netflix and LinkedIn and whatever. That's where you go when you go to GitHub and you pull in all these things. And that's the state of the art. And it's largely low cost or free. You can buy support for it. But you can assemble these systems, and this is like a golden age for building distributed systems. If you go back 10 or 20 years, you would have needed huge teams and huge budgets just to buy the software, let alone the hardware, to build anything like this. So it's fantastic now that anybody can pull this stuff together, anyone can deploy it on the cloud. A one-man company can build a distributed system at global scale that it would be completely impossible 10 years ago. So that is amazing, and as somebody now in the VC world, I'm seeing these things pop up all the time. The other thing then is to think about GitHub as both the developer's resume. So if you're interviewing people, what's your GitHub ID? You want to read your code. Why don't you have a GitHub ID would be a good question. Follow on if you did get the right answer. And then it's also the company's resume. So you go to GitHub's Netflix site, and there's an enormous amount of stuff there. That starts to attract interesting developers to Netflix who like working in open source. So there's a kind of a flocking effect. People like to work together with people that they know publicly. So really encouraging lots of companies to go, and government organizations and whatever, they're all going out now and starting to create things like GitHub sites. And you're trying to build ecosystems around it. And the final point here really is licensing. If you see stuff that's licensed with a GPL, the Affera GPL, that means I didn't want to open source it in the first place, but I wanted to call it open source because it's incredibly hard to contribute. You don't get an ecosystem building around an AGPL product. It's a product that, yes, you can read the source code. That's really about it. Apache license is the one that Netflix adopted, and you basically, if you do it right, then everyone in the company, the organization says, if it's Apache, you can contribute, you can put things out there, it's easy to deal with, and it's a very flexible license because you have the ability to fork the code and build your own version, but very few people will, because if you fork it, then you have to maintain it, and you have to keep rebasing back to the original, resyncing to the original. So there's an economic incentive to not fork code rather than so it's like a carrot instead of a stick, right? GPL is a stick and Apache is a carrot. So that's the sort of pattern that I've seen working very well. You get much better ecosystems around Apache license projects. That's what's really matters. So development. You're going to have to build lots of services. The services have APIs, and the question is, how do people consume those APIs? If you're consuming them at the front end with a browser, and you're consuming JSON objects, and you're talking to those JSON objects directly with JavaScript, or maybe sort of Python or something like that, you can consume them directly. But typically, that's the edge services, right? So edge services and public services, you want to have a stable public API where the protocol is in the object. XML does the same thing, but it's just so much more work to process XML that JSON is more lightweight. But within your services, within your service architecture, you've got lots and lots of calls going back and forth. It takes too long to process XML, certainly, and JavaScript is also relatively inefficient if you're passing it around at high speed between microservices. So you want to compact binary encoding, something like Google Protocol Buffers is commonly used, Thrift or Avro, or there's a new one called Simple Binary Encoding, SBE. If you're into this stuff, it's 20 times faster than protobufs. That's the latest interesting one I've seen. So you've got all these in binary encodings, and you want to be able to consume a service. So you end up writing a library around it. Now either the owner of the service writes a library and publishes it and people use it, or The consumer of the service will write a library probably badly, not really understanding exactly how to decode everything and not quite getting the error handling right, and then give it to their friends. So you either own your client libraries or you get a mess. And you see many examples of this where people say, no, my API is self-describing, I will not write a library, and then they get this library that they didn't write forced back onto them to try and adopt, and it's a bad situation. So you can have the argument over this either way, but the end outcome is always the same. Whether you like it or not, you're going to own a client library. So the best strategy is to build at least one reference client library in a well-known language that shows how to build it. And if people want to use another language, maybe they copy stuff from that library, right? So build a Java one, and people will go figure out how to build a Ruby one or whatever. But build the ones that really matter to you. You should curate them and manage them yourself. So the next thing that happens when you have microservices is you hit a front end, and that service will then explode out and try and call maybe 10 or 20 other services. So how do you manage that? Right? How do you call 20 things? How do you call 20 things at once? There's like callbacks or multi-threading. If you do something sequentially, it'll be horrible. So you have to figure out a way to effectively multi-thread or do callbacks. And the nice model here, the reactive model, deals with this by using RxJava to give these levels called observables. So basically you make everything observable. Behind the observable, it implements it some way that you don't need to worry about. You basically compose together all these observable values, and once they all become observable, you get your results and you package it up and you send it off. So it's kind of a layman's approach to that. So if you're trying to solve that problem, go look at the Rx stuff. It's becoming a very popular pattern for doing this, and it's got some very nice attributes that make it a very clean way to define that interface. Circuit breakers. So the other thing is, if a service dies or breaks in some way or starts getting really slow, the calls to it will back up. And that tends to cause the next service up to back up. And that chain can go all the way to the customer, and you get a chain from some back-end database gets slow and everything it ripples through the system. So you have to have a circuit breaker to isolate that and stop it from spreading. And the circuit breaker code that Netflix built is called Hystrix, and it's got quite popular. There's quite a few people implementing it now in various other packages. But the idea is that you wrap everything in a thread, and if it breaks, you just stop calling the service, flip the circuit breaker and tell somebody, hey, this dependency is no longer working for me. So the circuit breaker acts like an electrical circuit breaker. Every now and again, you go and try it again to see if it got fixed, and it'll pop back or it'll stay on. That's the general idea. If you're doing things on AWS and on the Netflix mechanism, there's a whole bunch of names there of the Netflix projects. A similar kind of functionality is available, particularly if you're doing Scala, and particularly if you're doing stuff in your own data center and are less AWS-centric, then Finagle and Zipkin from Twitter is a useful set of things to go look for. So now in the back end, you've got a data store, and if you're starting with an monolithic data store, you've got to split it up. So you've got to refactor your database. So there's a book you can get to go look at that. And there's things like Schema Spy you can do to go and look at your schemas and break everything out. But what you're trying to do is one at a time break off the materialized view of the table that your new dependency microservice needs and take it out of the combined backend. Usually if you actually look at what's really in that big MySQL that's sitting behind everything, there's a collection of random things, and the services that talk into it talk to different parts of those random things. It's usually fairly easy to separate out. And you can do it incrementally, pull things out. You can also do a gradual move. There's one of the Netflix projects is called Stash, Storage Tier as a Service. This is a common front-end REST API Java app, and behind it, it talks to Cassandra and MySQL, but you use a REST interface into the front end to do that. So you can interpose this as a standard prototype library for developing data access layers. It's just like the generic data access layer. You could add a new database into the back end, you could add new HTTP into the front end, but it's already got all the MySQL and all the Cassandra and all the glue all put into one thing already. So that's a good place to start. And then if you're playing around with data stores and you're trying to understand when you can be consistent, when things need to be distributed, if you haven't looked at Carl Kingsbury's Jepson tests, then you should definitely be very familiar with that. This is becoming like the standard way that everybody, well, Kyle anyway, he destroys all of the distributed systems databases, and pretty much everything has failed to pass his tests, and he finds all kinds of interesting bugs. So there are certain things which people do with data stores which they really shouldn't be doing, and this highlights that. And then, I'm a physicist, so there is no such thing as a distributed system that's consistent because of speed of light and Einstein and whatever. But you could argue with software developers that you can pretend that the thing action at a distance is simultaneous. So I've got a few more things to talk about, and then I'll wrap up. Cloud native monitoring. So you've got all of these systems and lots of services, and you're trying to monitor them. And the problem with cloud native monitoring is the very high rate of change. You're introducing new services, they're scaling up, they're scaling down. You get new instances, new metrics, new versions of things. And if you've got anything doing automated threshold analysis, there isn't enough baseline for this thing to learn what normal looks like, so you tend to get lots of false alarms, particularly if you start a brand new service that's it's never seen before, or things are coming and going fast. So you have to figure out a way to build transitional systems that will automatically do the right thing. So it's not necessarily it's just something that you're going to have to deal with. The problem is that everything looks unusual all the time because everything is changing so much. And then these short lifetimes, it's hard to aggregate historically. You have to find new ways to aggregate things. You can't aggregate by IP address because IP addresses may only last an hour and go away again, for example. And then if you're using sort of hand-tweaked Nagios to manage everything in your data center, you'll go crazy very quickly. You need to have stuff that's very automated. So the act of putting something up in the cloud, your platform should automatically instrument it, monitor it, and start drawing graphs for it. There should be no other step, and this is kind of the Netflix approach. You launch something in the cloud, then you go over here, and there it is. There's some data for it. There's a CPU, there's the traffic coming into it, whatever's going on, right? So it needs to be that automated. And the problem then is that you need to measure end-to-end request flows and figure out this called this, called this, called this. You can instrument HTTP headers with the GUIDs and transaction IDs, basically. That's how App Dynamics works. It dynamically adds those to Java code for you, so you don't have to put it in your own code. Or you can add it to something like Ribbon and Carry On. And then you've got to visualize that, and one of the problems with App Dynamics is if you put too much stuff in it, it sort of blows up. So at the Netflix scale, it was too hard to get things to look right. So how many services should you have? This is a slide from Guild Group presentation from last year. Going by that trend, they're probably at 600 by now, because that's about a year and a half or something. So how many microservices should you have? Well, it's just you just keep making new ones every time you're doing new functionality. And the more you make, obviously you're being really productive now and you're making lots of new features. So that's good. So there isn't a problem, except that you have to figure out how to monitor them. This is the architecture diagram for one of the versions of it from Netflix, and Twitter's got the same diagram. That's a very cut down version of the Guild diagram. And then I saw a Groupon presentation that had exactly the same shape on it. I call this the Death Star architecture. Everything is talking to everything. All you can do is arrange the icons in a circle, and they'll overwrite each other, and you won't be able to read anything. So it's kind of, you just have to deal with this. Yeah, I'm sorry there isn't an architecture diagram. Sort of get over it. Okay? For a particular request coming into the system, you can trace the architecture through. But there are very few tools, and this is an opportunity as well. There are probably ways to tease architecture diagrams that will be useful out of this. It's just, this is an emergent area. If you're looking for something to do in microservices, and you're a UI designer, please go work on this problem. I tried posting, I got the App Dynamics guys to post a printout of that in their UI designers cube for 2 years, and it didn't work. So, well, that was what I asked them to do anyway. So let's look at continuous delivery. You're basically making lots of small changes to the system, and very frequently. Individual changes are more likely to be broken. You could make a change, because typically the changes that break things aren't deploying code, they're enabling a feature. So you decide, okay, this went through testing, it's fine, turn this feature on for everybody. Turns out that code's 10 times less efficient than the old code, and your site then immediately tanks. Or that's happened. or you suddenly discover that everybody in Latin America blows up when you do that, or something like that. So there's some unforeseen effect caused when you turn on a feature flag. And the problem then is, how long did it take you to figure that out? So there's this whoops, I didn't mean that reverting cycle. And if you have your monitoring system collecting data on 1 minute boundaries, which is pretty common, it might take you 5 minutes to notice that this metric has moved. Like, oh, there's one metric, is that one? Oh no, there's two down there, okay. And it takes a few minutes to collect data. Now if it's 5 seconds, then you'll sit there. I mean, the other problem with it taking minutes is that you flick the switch, you go, I'm bored, I'll go get a cup of coffee. And then you forget about it, and then you're chatting in the break room, and then everyone's running around, oh, there's an outage, didn't you know? Oh, I caused that, sorry. Right? And you run back and fix it, right? Whereas if it takes 10 seconds, or in some small number of seconds, you will sit and watch it before you go and get your cup of coffee, and it will be working fine, right? Then you get your cup of coffee, right? And if it breaks, the other thing is to always remember the previous version of any configuration change and log that centrally so everyone can see that you just flipped this to this, and then hell broke loose. Okay, we'll switch it back. Oh, that fixed it, good. Right? But if you don't know what the previous value was, then you can't flip it back safely. So this rollback of configuration variables matters as much as rollback of code. This is what the circuit breaker looks like. The bottom right shows a one that's been flipped into the circuit breaker's tripped and it's 99% failing. The circuit's open. So if you're looking at this, oh, by the way, this is part of the Hystrix is the circuit breaker system, and Turbine is the aggregator that takes a whole lot of circuit breakers and turns it into something your web browser can view. So this is your web browser connected directly to the machines that have the circuit breakers in them. There's no collection system in between. You're directly doing WebSocket, pushing bits of JSON into your browser. There's no tool here. It's just code and JSON, and it just works. And it's very, very fast update, very low latency. So if you're going to push new code, you launch this browser and look at it, and then flick the switch. Okay, that looks good. I'm done. Right. If you want a centralized SaaS-based system that looks at 1 second updates, there's a couple of them that I'm aware of right now. Vivid Cortex is a MySQL, or generically it's a database monitoring tool, but it specifically does MySQL monitoring by looking at the packets flowing through the network on a 1 second interval. It can see problems and glitches at this very, very fine grain. They're actually a company that Battery invested in last year, and I've been working with them for the last few months, sort of helping them and sort of working through their go-to-market. Boundaries are also 1 second update, sort of network-focused monitoring tool. This is very useful for monitoring distributed databases like Cassandra, where there are flows going in all different directions, and that's the use case that they've used at Netflix.